Good morning, and welcome to our first lesson on factors and roots. And this is the first of two lessons before we get into a lot more factoring, which I know you'll be thrilled with, where we look at the relationship between factors, and then you'll notice this vocabulary hodgepodge here of roots, zeros, and x-intercepts. Oh, hang on. I had singular root. It's roots, zeros, and x-intercepts. Roots, zeros, and x-intercepts are all words for the same thing. Now, before I do this, I've noticed some mistakes on classwork and tests that I want to clear up. This is not a universal error, but it's common enough that it merits being addressed in a whole class session. So I want to really clear up the following things. What is the x-axis? What are x-intercepts, and what are x-coordinates? Because what I have noticed on two tests ago is that it says label the x-intercepts, and people look at the x-axis and they label that the x-intercept. Or I ask, what is the x-intercept? And people give me the x-coordinate of a point. And so there is enough confusion on this that it is worth taking about 2 or 3 minutes of a class period to make sure that we distinguish between x-axis, x-intercepts, and x-coordinates. And the same could be done for y-axis, y-intercepts, and y-coordinates, because they're not the same thing. And if I am saying x-intercepts, and in your head you are picturing the x-axis, then that is going to make for an incredibly confusing lesson for you. All right, so let's go talk about these. We're familiar with the coordinate plane. This right here is the x-axis. It is the horizontal axis on the coordinate plane. So this is the x-axis. This one is the y-axis, but we'll keep it to just, x's today. On the coordinate plane, and we do get lazy, sometimes teachers will call this a graph, and it's not. Graphing is what we do on the coordinate plane. And so on the coordinate plane, you would put a graph. Now, this particular graph has 3 what are called x-intercepts. And intercepts are actual physical locations. They are not numbers. They are points where a graph crosses the x-axis. And a polynomial can have 0, 1, 2, 3, like a bunch of x-intercepts. When you get into trigonometry, like a sine wave can have an infinite number of x-intercepts. Those would be the points where the graph crosses the x-axis. Now, on the graph, there are an infinite number of points. So what kind of color do I? Let's use a gray. And so we could just pick like a point, any old point. And that point comes with an ordered pair. The number on the left-hand side is the x-coordinate of a particular point. So whatever number is right there, that would be the x-coordinate. So I'll give one more example here. So this is a graph of something, okay? The x-axis, that is the x-axis, okay? It's always the horizontal axis. This particular graph has 2 x-intercepts. And the x-intercepts are at -2, 0, and 2, 0. So there are 2 x-intercepts. Sometimes we'll list them as ordered pairs to remind ourselves that they are actual locations. Other times you might just hear somebody kind of do like -2 and 2. And that is because it is assumed that you know that the y-coordinate is equal to 0. Okay, and that it's not lazy, it's just kind of a given that if you're talking about the x-intercept, that the y-coordinate would have to be a 0, and so we don't have to say what would be like obvious or apparent. Now, on this graph, there are an infinite number of points, and each of those points has a x-coordinate. So the x-coordinate of this point is a 3. Okay, now this is the y-intercept because it's where it crosses the y-axis, and we would say the x-coordinate of the y-intercept is 0. Okay, and that's because it's that number. It's in the x position of the ordered pair. There is enough, like I said, there's enough confusion. I see enough mistakes with how people respond to questions to know that those definitions and the distinguishing, like how they're distinguished from each other, it's not universally well known. And so I hope that does clear it up, because what we are focusing on in this lesson, if I go back a slide, are the x-intercepts. And so we just need to be really, really clear that what we're talking about today is where a graph crosses the x-axis. Other words are roots and zeros, and I use them interchangeably. So I will sometimes say root, I will sometimes say 0, and I will sometimes say x-intercept. So you need to be fluent and able to go back and forth between those vocab words. Now, what I just did also sets up for what we are looking for here. So I'm going to kind of quickly do another graph, and I want to set up the concept. Okay, so we have a coordinate plane, we have some kind of graph on it, and we remember that the x-intercepts are where the graph crosses the x-axis. Now, on each of these x-intercepts, these are each physical locations on the coordinate plane, and if you were to look at the ordered pairs, what you would notice, I hope, is that the y-coordinate for each of those ordered pairs is 0. Now, I don't know what the x-coordinate is because I don't have any tick marks on this particular coordinate plane, so I don't actually know where those points are, but I do know that the y-coordinate of the x-intercept is always 0. So I'm going to actually write that down. Y-coordinate of the x-intercept is always 0. And I'm going to just pause in the video here, just pause my talking to give you a chance to think that through. So suppose you had this equation or function, okay? So y equals x plus 2, x minus 4. Notice that this is in factored form. Okay, so this is not in standard form. Last class, when we were doing degree and leading coefficient and everything at end behavior, we needed the functions to be in standard form. This is factored form, meaning it has been factored, and you can see the two factors there are x plus 2 and x minus 4. Now, if you were asked, what are the x-intercepts? So if you were asked this, what are the x-intercepts? Then what you're going to remember is this fact over here. The y-coordinate of the x-intercepts is always 0. So that means y is equal to 0. So you take out the y and you put in a 0 because of what you're being asked. You're being asked for the x-intercepts. So therefore, you know that y is equal to 0. And this turns it into a garden variety quadratic equation that we were doing through a decent chunk of November and December. If you have two things that are multiplied together and the product is 0, then either the first factor is 0 or the second factor is 0. Here we'll subtract 2 from both sides. Here we'll add 4. You don't ever have to write that out. And we get x is equal to negative 2 and x is equal to 4. So I mentioned back here that we will often, when we're talking about the x-intercepts, we will often write it just as like the x value because we know that the y value is 0 because that's implied by definition of what the x-intercept is. So you can write your x-intercepts as ordered pairs, or you could write them just as like the value of x. So you could write them as x equals negative 2, x equals 4, or you could write them this way as the ordered pairs, remembering that the y-coordinate is 0. Back when we were doing lines and we're doing the y-intercept, I mentioned that Miss Braswell makes her students always write the y-intercept as an ordered pair so that you don't forget. that it's not a number, it's a location, it's an ordered pair, a point. Okay, now this concept also works for higher degree polynomials. My handwriting leaves something to be desired. But now notice how we're using the new vocabulary. So we're using degree, we're using polynomial, and as the math builds, this vocabulary needs to get added into your math vocabulary so we know what we're talking about. So let's take a look at another example. If we have y equals x minus 3 times x plus 5 times 2x plus 1. Again, notice that this is in factored form. So we have three factors here, x minus 3 times x plus 5 times 2x plus 1. If you are asked for the x-intercept, we know that the y-coordinate of the x-intercepts is always 0. So if the question is, what are the x-intercepts, then you're going to take out the y and you're going to put in the 0. Because that's what x-intercepts means. It means the y-coordinate is equal to 0, which is also why zeros is one of the words for the x-intercept. And so that's why it's called zeros, because it's where the y is equal to 0. So we'll kind of like keep tying that back into the vocabulary there. Now, using the zero product property, if you have three things that are multiplied together and the product is 0, then you know that one of those factors has to be equal to 0. And it could be any of them. Here, if I add 3, I get x is equal to 3. If I subtract 5, I get x is equal to negative 5. This is a two-step equation, so we'll subtract 1 and then divide by 2, and we get x is equal to negative 1/2. This particular function actually has 3 x-intercepts. You can leave them written this way, x equals 3, x equals negative 5, and x equals negative 1/2, because we know that the y has to be equal to 0, or you can write them as the ordered pairs. So you can write them as 3, 0, negative 5, 0, and negative 1/2, 0. Now, at this point, you might notice that there's a bit of a pattern here, and you are free to take a shortcut. In fact, most proficient math people will take a shortcut here. So here's the shortcut. So you are free to just flip the sign. Flip the sign and skip to the answer. Okay, you are free to do that. So if I were to give you this function, y equals x minus 7, x minus 3, x plus 2. Okay, and I say, all right, tell me, what are the x-intercepts for this? You can go through this whole thought process where you replace the y with the 0, because again, definition of x-intercept. And then you take each of the factors, you set each of the factors equal to 0, and you independently solve all of them. Or you might notice that if you have a minus 3 in the parentheses, then the answer or solution is a positive 3. If you have a positive 5, then the answer is a negative 5. Over here, a positive 2 resulted in an answer of negative 2. A negative 4 resulted in an answer of positive 4. So what I hope you're noticing is that you're just flipping the sign. It's because of when you solve the equation, you do the opposite operation. That's why the sign flips. But math is consistent, and it's always going to work out that way. So you are welcome to simply do this. X is equal to 7, x is equal to 3, x is equal to negative 2. And just go ahead and flip the signs. Okay, now if you have a two-step equation like this one here, I can do this in my head. So I can do like, I'm going to subtract 1 and divide by 2, so it's going to be negative 1/2. You are free to do that as well. So if that is an easy step for you to take, I want you to feel free to totally do that. If you can't, or if you need to write it out, then please do. I don't want you doing stuff in your head that you're not comfortable doing in your head. Now, one last thing before I give you the practice problems, and then we'll actually finish the lesson. In this particular problem, I do want to go over the vocab. I know you guys get probably super, super sick of Miss Taylor and her vocabulary. Sorry, but not sorry. These are what are called the factors. Okay, so x minus 7 is a factor, x minus 3 is a factor, and x plus 2 is a factor. These are what are called the roots or the zeros or your x-intercepts. Okay, and I want you to take a moment and stare at that and make sure you know the difference between what the factors look like and what the roots look like. Factors are things that are multiplied together. In this case, x minus 7 times x minus 3 times x plus 2. Roots are the actual physical locations of these points where this particular graph would cross the x-axis. And you can be asked for factors, you can be asked for roots, you can be asked for like different things, and you need to know what the difference is between them, or you're going to end up answering the question wrong. Because like on a multiple choice test, it could say, what are the roots? And the factors will be one of the answer choices. And if you're not sure about what's a factor and what's a root, you'll pick the factors when you should have picked the roots. Okay, so for some practice problems. So for these 4 practice problems, just go through and state the roots. Tell me what the roots are. So we'll stop the video here for in-class review, or you can keep watching and I will go over these out loud. For the first one, you could answer this as either x equals 4, x equals 2, or you could state the ordered pairs. So 4, 0, 2, 0. For the second one, you can say x is negative 1 and x is 1, or you can state them again as the ordered pairs. For the third one, we have x equals 3, x equals 4 thirds, because you're going to add 4 and then divide by 3, and x equals negative 6, and of course that's 3, 0, 4 thirds, 0, and negative 6, 0. And for this last one, x is equal to 2, or the point 2, 0, and notice that it appears twice. So you're actually getting the same root twice. And we talked a little bit about that the day before the holiday break on the 18th. We did go over that one in our lesson on discriminant. If you were one of the many people that was not present in class that day, I would encourage you to go back onto YouTube and watch the video presentation on that, because it will plug a couple of gaps in there. Now, what I would like to do at the end of this lesson, we're going to stop this, and we're going to graph these on the calculator to confirm. And that is where we'll end this lesson, and where we will pick up on the next lesson on factors and roots.